Hi everyone! Today's topic is factorization with skelting and primarization, the continuation of video 17 and 18. Even the coefficients are a bit bigger. You can factor it correctly and quickly. Okay, let's get started. We hid the exponentials of x in video 17. Let me call these exponentials expo x collectively. This time, we hide expo 2. For ternary notation, I'll show you how to use it. This expression has expo 3, 139 in each coefficient as a factor. So hide it through division. After factoring it, get back expo 3 to each coefficient. You can omit writing these expos. Next example. This expression contains expo 3 downwardly. So let's hide it through division. Call this notation over ternary. The usage is the same. It has expo 2. So hide it through division. After factoring it, unhide expo 2 through multiplication. Next example. You can hide many expos. 3 over ternary notation. After factoring the skeleton, distribute 3 to the x's place and 2 to the 1's place. Let me call this hiding and unhiding process skeleting. Now, the principle behind it. When an expression has expo 2, we can take 2x as y. After factoring it, substitute 2x for y. It's done. We skipped the substitution process, hiding and unhiding expos. When an expression has expo 3 to the right, factoring out 3 squared, you can take x over 3 as y. After factoring it, substitute x over 3 for y. Then distribute 3 to each factor. We skipped 3 squared and substitution. You can do skeleting also in high degree expressions. Next example. Before making table 144, as in video 18, look for expos first. Expo 4. We hit Expo 12. Here is an important tip. When the skeleton is unfactorable, so is the original. When it needs square roots to factor, so does the original. This is the end of the factorization, only with integer. Next example. After skelting, you can use the quadratic formula, exposing 2 and 3 like this. Go to video 21 for details. Move on to primarization. The ones place has many 2's, 16. But the x place has no 2. Take this one and so. When the expression has 1, 1, many 2's, a failed expo, you can take this 16 as a prime number. If it was a prime, you can easily find the pair without the factor table. Wait a minute, how can 16 be a prime number? Well, let me use dominant notation as in video 17. To factor this, we need to split 48 into 2 numbers, which makes the sum 19. But splitting 16 makes 2 even numbers, like 8 and 6, whose sum never makes an odd number. So we cannot split 16 as if it were a prime number. 148 goes wrong. 316 goes well. Once again, the ones place has many 2's and 3's, but 35 has no 2. It has 1, 1, many 2's, a failed expo, and 35 has no 3. It has 1, 1, many 3's. If so, take 8 and 27 as prime numbers. Having only 2 primes, you can find a pair easily. Splitting 3 cubed makes 2 3's multiple, like 9 and 24, whose sum is 3's multiple, but the x place has no 3, so we cannot split 27. Once again, even with negative, primarization works. 7 has no 2, a failed expo. 7 has no 3, a failed expo. No need for the factor table. Once again, there are single prime numbers only. It means no number to primarize. If so, just make the factor table. Move on to the Terminator next. The ones place has only single 2 as a factor, and the x place has 2. It has another failed expo, only single 2. If so, we cannot factor it only with integer. The principle is simple. Whatever the pair you make, the single 2 makes only one of them even, and the other odd. So the sum is always odd, never becomes even. The same goes for other numbers. The ones place has single 3, and the x place has 3. Another failed expo. If there is 1 3 single 3, you cannot factor it without square root or I. Whatever the pair you make, the single 3 makes one of them 3's multiple, the other not. The sum is not 3's multiple. Is this the end? Not yet. It has expo 2. Is this the end? Yes. With Terminator 1 2 single 2, it is unfactorable. And so is the original. How about this? Not yet. It has common factor 2. Is 1 2 1 the end? Not yet. The sum of two odd numbers is even. Next example. It is Terminator single 3 3 1. You cannot factor it. According to the mirror principle in video 17. Next example. Together with the product ratio, you can primarize 8 and 27. Go to video 20. You can factor it easily. Next example. When it's hard to factor the ones place, just use square completion and the hinge product. Go to video 21. Next example. We can hide expo half by multiplying expo 2, like this. Then finding 3 and 8, distribute half to 3 and 8. Once again, to hide this 10, multiply expo 10. It luckily hides this 5 together. After finding the pair, distribute 1/10 to 8 and -5. Once again, this 3 requires expo 3, and this 4 expo 2. Then multiply expo 6. After finding the pair, and height 1/6. Okay, let's move on to the drill. Factorization continues in video 20. Product ratio method. Okay, thank you for watching. See you next time. Bye.